So this video is going to be going through an activity that's on pages 327, 328, and 329 in the workbook. And basically on page 328 and 329, we have these 15 graphs of functions, which I cut out. And so I know that these are in sets of three. 5 sets of 3, where one graph represents a function, the second graph represents its first derivative, and the third graph represents its second derivative. And the idea is to turn these 15 individual sheets of paper into those 5 sets of 3. So let's see me going at this. All right, so first thing I'm going to do is I'm going to take these graphs. These are all polynomials, I notice. So what I'm going to do is I'm going to sort them by their degree. All right, so for instance, this is a linear function. So I'm going to put, here's another one. This is a quadratic function that is also quadratic. This one is a cubic function because it's got 2 turning points. Another cubic. This one has 3 turning points, so that's what we call a quartic function. There's another linear function, another quadratic, another cubic, quadratic. This one is a quintic function, and then we've got a quadratic function. So hopefully I did that correctly. So why don't I sort these from the top going down, at least to start. All right, so I'm going to start with this graph right here. So this graph has 1, 2, 3 turning points. Now, where are those turning points? It's got a turning point at 1, 2, -3. Looks like another turning point at at 0, and a third one at 1. So let me go through all of the cubic graphs and see if I can find a graph that has, since these are going to be the turning points, in the derivative, those would be zeros. So I want to look for a graph that has a 0 at -3, 0, and 1. And it looks like it's probably this one. That one doesn't have 3 zeros, neither does that one. And that's it. All right, so here are, this graph goes with this graph. And let's see if we can find the second derivative of this function, which would be the first derivative of this function. And I'm going to go through the same process. So this has a turning point at -2, I suppose, and maybe about 1/2. So let's see if we can find a quadratic graph that has a 0 at 2 and maybe around 1/2. No, no, this looks great. All right, and let's just see if the rest of them are also no's. Okay, so here is one of my triplets, and I'm going to move that off to the side. Okay, let me pick the other quartic graph here. So this has turning points at -1, 0, and +1. So those are the turning points. So the derivative is going to have zeros at those points. No, no, no. All right, so here's my graph with turning points with zeros at -1, 0, and +1. And so the derivative of this graph, which would be the second derivative of this graph, is going to have zeros at about 1/2, +1/2, and -1/2. So this is going to be as tight a parabola as this is a tight cubic function. Oof, okay, could be this right here. Let's take a look at the rest of them. Nope, and nope. All right, so there is my second group of functions. All right, and so let me take a look at the remaining cubic functions. So these are going to be third derivative functions, and then I've got second derivative and first derivative. So let's see where we go with this. So this graph has a turning point at -1 and, I don't know, +2, maybe a little more than +2. Let's see if we can spot that. Yeah, that's this one right here. So the other two we can see are kind of symmetric. All right, so where am I going to find a graph now that has a turning point at somewhere between 1/2 and 1, maybe? This one's going through the origin, so no. That third one is also going through the origin, so this is the first derivative of this function, and so it's the second derivative of this function. And there's my third set off to the side. And let's look at this. So this has a turning point at -1 and +1. And here the turning points, or the zeros, are at -2 and +2. So this is the derivative of that function. And let me pair up these other two. So this has a turning point at -2 and +2, and this has a 0 at -2 and +2. And so the only question is, which of these two graphs is the derivative of this function and which is the derivative of this function? Well, this one, they both have zeros at the origin because both of these parabolas have turning points at the origin. And so the difference between them is this one is steeper. So it's going to have a steeper graph because this is growing faster than this. So that's going to represent a faster growing slope. So those are my 3 sets of 5 graphs. And I took the numbers of them and put them in at the bottom of page 327. So you can compare your notes to mine. So one set was 2, 13, and 7. And notice that 2 is the function, 13 is the first derivative, and 7 is the second derivative. The second triple was 4, 5, and 8. Then we had 9, 12, and 3, 10, 1, and 11, and finally 15, 6, and 14. All right. But the point of that is that we can look at graphs and recognize, given a graph, we can recognize what the key features of its derivative would be. And so we can look through a bunch of graphs of derivatives and identify which one must be the derivative of the function graph that we're looking at. So that was kind of a fun activity. In the next video, we're going to go to more of a routine thing that we are going to do with functions, which is looking at the equation of a function and then kind of piecing together what the graph would look like. So look forward to that in the next video.